Alright guys, we have been talking about exponents for the past few classes, and we've been talking about radicals for months and months. So what I want to do is I want to show you how they actually relate to one another. But before we start that, I first want to just elaborate a little bit more on exponents and a little bit more on radicals so that you can connect some things you already know to what else you can do. In exponents, we know that if I were to take x, y to the third power, that really is just, quote, distributing, or that means that each one of these is to the third power, so therefore that would be x to the third times y to the third. Okay, so we already know that one. So then what I want you to realize is that you could actually be given this end and realize that, oh, I can rewrite it this way, so I can actually multiply them. So for example, if we reverse it, we could say, all right, well, if I've got n to the fourth times m to the fourth, well, that's really just n times m, and they're all to the fourth power. So that's just the reverse, but it's actually more helpful if you actually have something but it has numbers in it instead. So let's say I have 3 to the fifth times 2 to the fifth. Well, if you notice, they both are to the fifth power right here. So that really means that it is this pair to the fifth power, just like those match and it's to the fourth. These match, so it's to the fifth. So really we can just say, well, that's just 3 times 2. And so that actually is just 6 to the fifth power instead. So what we're doing is we're matching our powers or our exponent so that we can then evaluate the bases. All right? And then that rule also works for division. So if we had something like 18 to the third over 2 to the third. Well, instead of actually figuring out what 18 to the third and 2 to the third are, if we can recognize, oh, they both are to the third power, that means that I can actually divide those two. So 18 divided by 2 is just 9. And then it's that 9 to the third power. And that number would be much easier to get. You don't have to do as much. You just put 9 to the third to the calculator. So if your powers or your exponents match, that actually means that you can multiply or you can divide those bases up. And even if you had, like instead of that being 3, if I said to the 3 over 2, to the 3 over 2, so even if you have fractions, still the same thing. It's to the 3 over 2. Okay, so we've got something similar with radicals. We already know that with radicals, you guys already know that if I have the square root of 2 times the square root of 3, that you can actually put those together. And that's the square root of 6. You guys know that if it's in the root, that you can actually multiply them up. Well, that also applies to any other type of root. So for example, let me move this up. We can also, use it for any other type of root. So if I were to say, okay, the cube root of 5 times the cube root of 4. Well, I could actually put those together since the cube roots match. So it's similar to the exponents, except now we're looking at the roots. Okay? So since the roots match, they're both cube, that means I can actually put the 5 and the 4 together. So that's the cube root of 20 instead. All right? So it really could go with any root as long as it matches. So if you had the fifth root of 2x times the fifth root of 3y, okay, since they're both fifth roots right here, that tells you can actually put those together. So that is the fifth root, 2 times 3 is 6, and then x times y, okay? And so instead of splitting things apart or looking at them separately like we've done, we can also reverse the rule and we can put them together. And so just like this last one right here, we can also do it with division. So if you had a problem like the cube root of 24 over the cube root of 3, okay? Well, the cube root of 24 over the cube root of 3, instead of trying to get them separately, if you recognize they both are cube roots, that really just means the cube root of 8, okay? Because 24 divided by 3 is that 8. Now, this actually works out. We haven't talked a lot about cube roots, but this actually works out. You need 3 of the same thing multiplied. And 8, remember when we did our patterns, we were saying what cubed and what cubed? Same thing here. The cube root of 8 is actually the number 2. Because 8 is 2 times 2 times 2. There's 3 of them, or it's 2 cubed. So since 2 is our common number, it actually simplifies all the way down to a whole number, which we're going to start seeing more and more of. All right, so that's the first thing I want you guys to realize, is that you can actually combine some of these things. You can multiply or you can divide them, as long as these exponents or these radicals, we call them indexes, match one another.